Hi, this is a course on feature engineering. We are looking at various discretization techniques. Today we are going to look at Gaussian binning. Okay, so first let's understand what Gaussian binning is. Okay, here is a Gaussian distribution image from Wikipedia. So the Gaussian distribution or normal distribution is represented by two values, mean mu and standard deviation sigma. So using these two values, we can generate a normal or Gaussian distribution. Now, there are certain distribution rules this data follows. For example, from the mean, if we take one standard deviation on the left, on the right side, that will cover 68%, 68.2% of the data. So here we have the mean, and on the left, we are looking at mean minus one standard deviation. So this width cover 34.1% of the data, and similarly on the right hand side. Now from this 1 sigma to 2 sigma, that will cover another 13.6% of the data. Then 2 sigma to 3 sigma, that's another 2.1% of the data. Then after this 3 sigma, we usually have very small, just about a 0.1 on the left, 0.1% on the right. So as you can see, 68% of the values are within one standard deviation away from the mean. So that's what the Gaussian distribution represents. Now what we are going to do is, for our given data set, we are going to compute the mean, and we are going to compute for each value how many standard deviations away the value is from the mean, and that how many standard deviations away we are going to use that for binning it. Okay, so here we are generating a Gaussian distribution with a mean value of 50 and the standard deviation 10. So mu will be 50, and the sigma, which represent the spread of the Gaussian distribution, is 10. Okay, so we have generated 10,000 values. Here we have, we can take this as a sensor or some other variable with time. Okay, now we are computing the mean and standard deviation here. So the mean 49.83 is close to 50. Now as we increase the number of data points, the actual mean will be very close to the expected mean, right? Similarly, the standard deviation. Okay. Now, so as I mentioned, we are going to compute how many standard deviations away from the mean each value is. Now that is represented by a quantity known as z-score. Okay. Let me comment this. Okay, so the z-score from statistics, it simply compute how many standard deviations away from the mean the value is, and if it is on the left hand side, it returns with a negative sign. If the value is on the right hand side, it returns with a positive sign. So here we are computing this z-score, or you can say the feature standard deviation, the number of standard deviations. Okay. And then, as I mentioned, it takes negative sign if it is on the left, positive sign if it is on the right. So here we are computing if it is on the left or right using this positive, negative, using NumPy aware function. And then finally, we are taking the absolute of the z-score, because we are only interested in how many standard deviations away, not the sign. Okay. All right. So this value is computed before running this code. So as you can see, it takes both the negative and positive values, and it gives this sort of distance, how many standard deviations away the value is. Okay, so here we are generating some images. Now this is our actual distribution. So as we expect, majority of the values are around 50 and the standard deviation is around 10. Now here the middle one that represents the sigma, and this one represents 1 sigma distance, 2 sigma and 3 sigma. Similarly, on the right hand side, this one represents 1 sigma, this one 2 and this one 3 sigma. Now the same data we are plotting using a box plot. So this one will be the median. It's a Q1, Q3. 25% of the data points are above this Q3 and 25% of the points are data points are below this Q1. As we saw from here, the Gaussian distribution, it's a symmetrical distribution around the mean. So we expect the equal number of values on the left as the number of values on the right. So that's what we are looking at here, the positive number of positives and number of negative. Now the actual feature transformation we are doing with this Gaussian binning is this one. So we are computing how many values are away from the standard deviation. So out of those 10,000 values, so as you can see here, about 6,800 values, those are within 1 sigma standard deviation. So out of the 10,000 values we generated, 6,800 values, those are in this dark bluish area. Okay, and the second region is the 2 sigma width. Now that would be some 13.6 plus 13.6, that's around 27-28% values. So this is that value, and then 3 sigma, and usually the values outside 3 sigma are considered outliers. So we have very small fraction of values after 3 sigma. Okay, here we are looking at the same plot, but it's normalized so that we can look at the percentage. So as we discussed, so within 1 sigma we have about 0.68, that's a fraction. So 68% of the values are here, maybe some 28% of the values are in this 2 sigma region, 26-27%, and then the couple of percent, around 3%, are in this 3 sigma, and very small fraction, less than 1%, are within this 4 sigma distance. Okay. All right, that's the feature. So basically we have transformed this continuous variable into some discrete variable using how many standard deviations away each value is from its mean value. Okay, that's what we call a Gaussian binning. Thank you.